In this video, we shall look at matrices and some of the operations associated with them. Generally, a matrix is a mathematical object in which numbers are arranged in rows and columns. For example, let's look at this matrix A. It has 6 elements: 1, 0, minus 1, 2, 3, 7. Now, as you can see, it has 2 rows and 3 columns. We say matrix A is of order 2 times 3. So the first number refers to the number of rows, and the second number refers to number of columns. If a matrix, say matrix B, has only one row, 2, 3, minus 4, such a matrix is known as row matrix. Of course, generally, it can have more than 3 columns. For example, a row matrix with 5 columns, let's say 1, 3, minus 7, 8, 0. So the order of such a matrix is 1 times 5. 1 row and 5 columns. Let's assume you have matrix D defined in a following way: 0, 3, minus 2, 5. So this is a single column matrix, and it's known as a column matrix. It has 4 rows and 1 column, and the order is therefore 4 times 1. Assume you have a matrix with equal number of columns and rows, such as this one: 0, 2, 5, minus 7. This is known as a square matrix of order 2 times 2, or 2 by 2. Another special type of square matrix is the following: 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So as you can see, the diagonal elements are all 1. Such a matrix is known as the identity matrix. And in this case, it is an identity matrix of order 4 by 4. Now let's get into the subject of labeling elements of matrix. In this case, you have matrix A, which is a 3 by 3 matrix. So there are 9 elements in this matrix A. Let's look at element 1. Number 1 occupies the first row and the first column. So we can write it as A with indices 1, 1. The first index refers to the row that element 1 occupies, and the second index refers to the column it occupies. Now what about that element? It occupies a row 1 and column 2. So it is A, 1, 2. Likewise, the 0 here is A1, 3 because it occupies the first row and column number 3. Number 4 now. That element occupies the second row and the first column. Second row and the first column. Now number 3, it occupies the second row and second column. Number 1 there, it occupies the second row and the third column. Now let's look at 7. It occupies the third row and the first column. Now minus 4. It occupies the third row and the second column. And finally 9. It occupies the third row and the third column. So these 3 elements are known as the diagonal elements of that matrix. So this is generally how we describe elements of a matrix. Let's look at some basic operations, mathematical operations that can be performed using matrices. The first one is summation. Assume we have these 2 matrices. Matrix A is 2, 1, 4, minus 3, 0, 2. And matrix B is defined as 3, minus 5, 1, 2, 1, 3. So both A and B are matrices of the order 2 by 3. In summation, or summing up two matrices, it's important that those two matrices that you're summing to have the same order. So let's try to figure out what is A plus B. That's pretty simple. All you have to do is to sum up an element with the corresponding element of the other matrix. So in this case, 2 plus 3, that is 5. And then followed by 1 plus minus 5, and that's going to give you a minus 4, followed by 4 plus 1, which is 5. You can do the same thing. Minus 3 plus 2, so that's minus 1. 0 plus 1, so that's going to give you 1. And finally 2 plus 3, and that's going to be 5. So that is the answer for A plus B. Now let's assume you have these two matrices. They are 2 by 2 matrices. A is 2 minus 1, 4, 3. Matrix C is defined by 1, 4, minus 2, minus 1. So how do we do A plus C? So you do element by element. This 2 should be summed up to the corresponding element of matrix C, which is 1. So 2 plus 1, that is 3. And then minus 1 plus 4, that's going to give you a 3. 4 plus minus 2, that's going to give you a 2. 3 plus minus 1, that's going to give you a 2. So that's the answer. Now what about subtraction? It works the same way. So A minus C, you do element by element. 2 minus 1, so that's going to be 1. Minus 1 minus 4, so that is minus 5. 4 minus minus 2, so that's going to be 6. 3 minus minus 1, that's going to be 4. And you see that's the answer. As we have expected, the final answer is a matrix of the same order as the original 2. Now let's look at multiplication. Now let's assume you have matrix A and it's given by 8, 0, 2, 1, 4, 3. So it is a 2 by 3 matrix. If you want to multiply A with a number, let's say 2, then the new matrix is 16, 0, 4, 2, 8, 6. So you multiply each element of matrix A by 2. Another example, let's say you have B defined by that matrix and you want to calculate minus 4B. So you want to multiply B with minus 4. So you have to multiply all the elements with minus 4. So the first element will become minus 16. The second one is 4, followed by minus 24. Now 1 times minus 4, so that is minus 4. 0 times minus 4, that is 0. 2 times minus 4, that's minus 8. 3 times minus 4, that's minus 12. 5 times minus 4, that's minus 20. And 1 times minus 4 is minus 4. So that is the answer. Let's look at these three matrices. Let's assume you want to find what is 3A plus 2B minus 4C is. As we have discussed earlier, let's just look term by term. So the first one is 3A. So 3 times A. 3 times matrix A, 2 minus 1, 4, 3. Plus 2B, 2 times B, which is minus 1, 1, 2 minus 4. And finally minus 4C. So minus 4, C is 1, 4, minus 2, minus 1. So that becomes, the first matrix is 6 minus 3, 12, 9. So we multiply this 3 with all the elements of the first matrix A. Now the second term plus 2 times all that. So it's 2 times minus 1 is minus 2. 2 times 1 is 2. 2 times 2 is 4. 2 times minus 4 is minus 8. Now minus 4 times 1, so that is 4. 4 times 4, that is 16. 4 times minus 2, that's minus 8. And 4 times minus 1, that's minus 4. So let's sum the elements. 6 minus 2, so that is 4. 4 minus 4, and that's going to give you a 0. Now let's move on to elements 1, 2. So row 1, column 2. You have minus 3 plus 2, so that is minus 1. Minus 1 minus 16, so that is minus 17. Moving on to elements occupying row 2 and column 1. So you have 12 plus 4, that's 16. 16 minus 8, so that is 16 plus 8. That's going to give you 24. And finally, the elements of 2, 2, which is in row 2 and column 2. So for the first matrix is 9. 9 plus minus 8. That is 1, 1 minus 4, and that's going to give you 5. In the next video, we shall look at how to multiply a matrix with another matrix. Here you will see that unlike multiplying two ordinary numbers, the order of matrices in the product matters. We will also look at the concept of transpose of a matrix, among others. Thank you for watching.